Hi ladies and gentlemen, this is Mr. Green and this is another in my series of lessons on pre-cal. We're continuing to look at graphing of the sine waves and things of that trig functions and so forth. We did the sine and the cosine last time, but I wanted to go into some things that might help you here a little bit. Where do you get the values for those points on the sine graph? Because, they show you getting the values and using them. Those all came from that unit circle. That's why I went over that unit circle a little bit. If you're having some problems with the unit circle and you're not really getting it, there's several really good videos on YouTube that are out there that I really do appreciate and like a lot. One of the things that's out there is a spaghetti unit circle video, and they use spaghetti. You know what spaghetti is. You've probably eaten that a lot. And a unit circle, and they show how they can calculate the heights to use on a graph of a sine wave. So it all goes back to that unit circle. If you don't know anything else, look up that left-hand trick. Left-hand trick? Well, that was another video I posted in the announcements that you'll be able to see out there. There is a left-hand trick that can help you with the unit circle. And I'll show you that here in just a second too, okay? So, what do we do with the unit circle? Well, using the theta that we've got and the y values, it gives you the sine wave. You use the theta and the x values, and you can get a cosine wave. You use the theta and you divide the sine by the cosine, and that gives you the tangent values. It really is very simple. If you just work at it a little bit, you can get the values in which to plot and get it to look like. Well, let's look at a sine wave. This is what a sine wave looks like. If you start here, it starts at 0. It proceeds up to 1. At what point is this x value when this is 1? Well, it's really pi over 2. It's 1/2 of pi. And then it'll come down here and it goes back down to 0. What value is it at 0? Well, that's at 180 degrees. That's at pi. And it goes all the way down to -1. That's at 3 pi over 2, and back up to 0. So it basically makes this type of a wave like that, and it looks like a wave running through the ocean, or a sound wave that's going along here. A couple things to note. The domain. The domain of this, it covers all x values. There is not anything left out of this, so it's all real numbers here. How about the range? Well, the range goes from -1 to 1, so it is inclusive, -1 to 1. This function is called an odd function. Why is it odd? Because if I try to take this point and graph it across the y-axis, it doesn't go straight across. I have to multiply it times -1 to get it to go across the y-axis. And it makes that x factor every time, that little x mark. Okay, that's called an odd function. That's something that we looked at earlier in semester 1, the odd and even functions. This happens to be an odd function. Okay, so what else do we notice about this sine function? It's periodic. That means it repeats. From here to here, that's one period. That's a function or a part of the sine wave that you'll need to understand. So it's actually got a 2 pi periodic behavior. So let's look at the cosine. How is it different? Cosine is different because at 0 here, it starts out at 1. It goes down to -1. This point right here is the point over here on the sine wave that was at the highest point. It's actually at 0 at that point. And that is at pi over 2. This is at pi. This is at pi over, or 3 pi over 2. And this is at 2 pi. It makes that same sort of thing. But it looks like a parabola, but then it repeats and repeats and repeats over and over and over again. Once again, domain, all real numbers. Range goes from -1 to +1. This particular thing is called an even function because the axis goes right straight through here, and you can actually just draw straight across the y-axis here. Okay? Y-axis doesn't appear to be showing, so let me just draw it in there real quickly just so that you can see where it is. Y-axis goes like that. Okay? So this is called an even function. You can use it back and forth across that y-axis. Okay? And then this one also has a period of 2 pi. From here to there is 2 pi. And it'll repeat every 2 pi over and over and over again. Okay? So let's look at the tangent function. Tangent function looks a little bit different. Looks kind of like an S curve here, doesn't it? Sorry. The domain here is still the same. It covers all x values except for these places where these little red lines are. Those are called asymptotes. And what's happening there is it never really touches at those spots. Okay? Those spots are actually at pi over 2. That first one is here. Okay? And then every pi, it repeats. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. But there's a formula for that. We just say pi over 2 plus or minus n times pi. Sorry, coughing fit. Had to take a drink of coffee. So the range on this one actually goes from negative infinity all the way up to infinity. So it's all real numbers in this situation. They get encompassed in the tangent. The tangent function is an odd function. Why? Because once again, I can't go straight across the y-axis to get to the values. I have to go through the origin here to get to the mirror image points here. And that's called an odd function. Okay? The tangent function has a period as well, where in the normal sine function and the cosine had a 2 pi. This one has repeated twice by that time. So it actually has a period. It has a period of pi. Sorry, phone now. This one has a period of pi. Okay, go away. Didn't want to go away for me. So it has a pi period. Okay? Let's look at the cotangent. Cotangent is actually 1 over the tangent function, so it is exactly what you think. It's 1 over, or the inverse of it. So instead of being at infinity, where the tangent was at 0, the cotangent's at infinity out here, right? Well, that's that asymptote. You can't touch it. But it does look exactly the same. It's just backwards s, right? The backwards s from the tangent. So what are we looking at? Once again, domain, all values except for every pi. It's got an asymptote. So it's all real numbers except where x is equal to n times pi. Some number times pi. Okay? Range, all real numbers. It covers all the real numbers on the range side. Cotangent function is called an odd function because you can't just draw across the y-axis and get get a mirror image of it. You have to go through the x-axis to get the mirror image of it. You got to go through the origin to get there. So it's an odd function. The cotangent is periodic, and it is the same as the tangent. It reoccurs every pi. So n times pi would be the period on that one. So secant function. Secant function looks like a u with an n and a u and a d. What is the secant function? Well, secant is 1 over the cosine. Remember that, right? So basically, if we go back and look at the cosine real quickly here, what do we see? Well, it was at 1, and then it was at -1, right? So let's look at the secant here. Well, it's at 1, and then it's at -1. That's exactly the same points there, because 1 over 1 is 1, and 1 over -1 is -1. But what it does is, in the other spots where the cosine was doing this, like that, this one has to go like that because it's 1 over the values that we were getting. That's where it goes up here to infinity. So this one does have some numbers that are left out of the domain. Those numbers are at pi over 2 and at 3 pi over 2. So it is actually pi over 2 plus or minus n times pi. Okay? The range of these numbers, it goes from negative infinity to positive infinity, with a break in between here. So what we say is the open parenthesis negative infinity to -1. Let's see if I can write that a little bit bigger. Negative infinity to -1, and we're going to put square brackets on that side, curled bracket on this side, and then on this side we would say from 1 to infinity. Those would be the two ranges that we would have. Okay, that gives you that break between -1 and 1. This one does have a periodic behavior. It reoccurs every 2 pi, so this value would be found again here, and then found again here, and that's if you have to add 2 pi onto it every time. So you'd say pi over 2 plus, or I'm sorry, the period is 2 pi. That's why we've got this n pi sitting out here for the uh, the asymptotes that could be eliminated. That didn't quite make sense to me, so but let me just assure you, asymptotes are at pi over 2, every pi over 2 up and down here. The period is 2 pi, so it's just reoccurring every 2 pi numbers. Okay, last one, cosecant. Cosecant is 1 over the sine function. So we do the exact same thing. We look at the sine function. It goes like this, and didn't do a very good job there. It goes through there, and it goes through there, and it comes up like that. Well, these values would be the same, and you can see it's going to make these little u's the same way. We've got the same asymptotes as we did in the cosecant, but they're occurring every pi times at this point. So the domain would be everything plus or x not equal to n times pi. So that's what you would be eliminating out of the domain. Range would be identically the same as to the secant. Okay, this is an odd function because we have to go through the origin to actually get a mirror image point that we'd be looking for. Okay, and its period is 2 pi. Now I ran through those kind of quickly, but the whole point there is you need to come up with some way of getting something that you can remember them. Now in the lesson they came up and they had you draw a little fourfold object to get that to work. I don't like the little fourfold object. Okay, I think the little fourfold object is a little bit too restrictive. We need to have a little bit more than that. Okay, so what I do is I actually create, let's see if I can get this to work now. Okay, let me see if I can get this actually to work. You guys are going to be really, really grossed out. There I am. Hi. I took a piece of paper like this, and I actually folded it 1/3 like this, folded it like that to get me 6 little windows. Okay? My 6 little windows have in them the, let's see here, sine. Hopefully you can read that. Too close. Sine, the cosine, the tangent. And then below the tangent I wrote the cotangent. Okay? And below the sine, or the cosine, I wrote the secant. And below the sine, I wrote the cosecant. And what I did on the inside was all that little data that I had just written about, I wrote in there, plus graphs and things like that, so that I could remember them. Made a nice little one piece of paper that helps me remember all those different functions and all those different values. Okay? And on top of that, on the other side, I made a unit circle, or at least part of a unit circle there. Okay? And I'm using that unit circle to help me get my values. The unit circle is something that helped me come up with the points that I was plotting. Okay? Okay, let's see here. Now, do this, and that'll go away. Thank you. Didn't mean to scare you like that, but that little fold like that might help you come up with something that can help. Now, I said I would show you the left-hand tool for the unit circle, because that unit circle is something that you use in calculus, and you're going to use from now on. So I'm going to actually just draw a circle here. Nope, that's not the circle. That's the circle. Okay. There you go. There's a circle. I'm putting in axes here. X and Y axis. Okay. Now, I'm going to take my little left hand, and I'm going to put my left hand right here. And I've got a thumb that sticks up like that. And I got a finger that sticks out like that. And I got another finger that sticks out like that. And I got another finger that sticks out like that. And I got a little finger. Okay? And that's my left hand. Very ugly little left hand. Well, I want you to notice this one's pointing straight up. That's 90 degrees. That's also pi over 2. That's easy enough to remember. I know this point on the graph because that's at 0, 1, right? And this one down here, this one's at 1, 0. I know that point. And this one's at 0 degrees or 2 pi degrees. This one is in the middle. It's pointing right here. That's at 45 degrees. It's actually half of going to pi over 2, so that's pi over 4. And this one is right there. You know where that one is? That represents 30 degrees. Okay? At 30 degrees, it's actually pi over 6. And this one up here is pointing up here. This is at 60 degrees. That's actually pi over 3. So those are the points that are on there. How do I find the x and the y values? Well, remember, my x and y values are actually cosine and sine. But there's a trick to doing this. What I'm going to do is I want to do this first one. At this one right here, if I want to find the cosine of 60 degrees or cosine of pi over 3, I've got one finger on this side, so I'm going to take the square root of 1. Yes, that's what I said. Square root of 1, which is 1 divided by 2. If I want to take the sine of this value right here, I've got 3 fingers on this side. That's square root of 3 divided by 2. Yes, that's all there was to it. To find 45, I got 2 fingers on this side. That's the square root of 2 divided by 2. And the sine value would be square root of 2 divided by 2. I'm using the extra fingers there. If I want to find this one, the cosine of this one is square root of 3 divided by 2. And the sine is the square root of 1, which is 1 divided by 2. I just found the x and y coordinates for each of these 3 points just by using my left hand and didn't have to do anything at all. It's the square root of however many fingers are on the left side of my left hand from that finger. Now, over here, quadrant 2. In quadrant 2, I'm going to take all my values from quadrant 1 and I'm going to make a negative x and a positive y. And it'll work out exactly correctly. So this one here, the one that is at 90 plus 120 degrees, the one that is at pi over, let's see here, we've got 2 6 plus 1 half plus 3 6 is 5 6, 5 6 pi. My x and y value at this point are going to be negative 1 half square root of 3 over 2. At this point right here, at the 45 degree angle, it's negative square root of 2 over 2, square root of 2 over 2. What is the angle at this point? Well, it's going to be, let's see here. If this is pi over 4, pi over 2, this is 3 pi over 4. You see how I'm doing that? What do I do for quadrant 3 down here? Well, that's really easy. It's negative x and negative y from quadrant 1. So whatever I had in quadrant 1, I'm going to make them negative x and negative y. And for quadrant 4 down here, I'm going to take my quadrant 1 values and I'm going to say positive x, negative y. Those will be my x and y coordinates. So the one right here, the very last one here at 330 degrees, or at, what do you want, how do I say this? Well, it is 5 over 6 pi. No, that's not right. It's 11 over 6 pi, because it's almost 2 pi. 11 over 6 pi. The x and y value here is going to be square root of 3 over 2, comma, negative 1 half. Do you see how I'm working those out real quickly using my left hand? I can actually fill in all of the degree measurements. I can fill in all the radian measurements. I can fill in all the x and y values. I know all the sine and cosine values of every one of them. And I also know the tangent values. How do I know the tangent values? The tangent's equal to the sine divided by the cosine. All I got to do is divide the y by the x. And I know the tangent. And I'm not using any type of calculator. This is how you used to figure it out before we had calculators. We knew these tricks, we played them, and we got these values down. And then what do we do for something that's given us 30 or 27 degrees? That was right here. Well, we knew the sine of 27 degrees had to be something a little bit less than 1/2. We just estimate it there a little bit. And if we needed to find the degree measure at 40, right here's 40, what do? Well, the sine at 40 degrees is something between square root of 2 divided by 2 and 1/2, somewhere in between there. That's how we use this unit circle to make certain we were getting values correctly when we didn't have calculators to do it for us very quickly. Okay? That's the hand trick. Hopefully that helped you with the unit circle a little bit. I do appreciate you guys letting me know that you're in pre-cal every time you send me messages. It helps me find your information quicker and respond to your questions. I look forward to seeing you next time.